All right, welcome everybody to our live stream. Today we have the pleasure of having not just one guest, but two guests. With me, we have Justin and Manan. Justin, how are you?
I'm doing great. It's awesome to be here.
Amazing. And you are in Argentina, is that right?
Yes, right now I'm taking a trip to Argentina, meeting with some of the applied AI folks here, and doing a lot of in-phase co-working. So it's been a great experience.
Amazing. Enjoy the ice cream out there. It's fantastic. And Manan, welcome. You're in Austin?
Yeah. Thanks, Ahmed and Justin. I'm based out of the Bangalore office, but recently I'm in Austin for our engineering offsite. It's quite a thing in our engineering culture, and we all flow in from around the world to kind of present what we are working on, what kind of ideas and thoughts we have. So right now, Austin is the place to be for all of our engineering folks.
Amazing. Another great city. So obviously I'm at home, and the three of us wanted to talk about a topic that I think is quite interesting, and I think our audience is going to find it quite interesting as well. And that is the role that clustering categorization plays in search. I think it also exemplifies how important it is to have a enterprise search solution that doesn't just have an index to your data, but also has some level of high fidelity access to information so that it can actually take actions such as clustering, because clustering can be so impactful to the overall search experience to get better answers. And so to begin with, maybe Justin, I'd love for you to maybe show a couple of examples of how in a test environment you could use clustering results. So we're going to start with the experience, and this is just one of 50 things we can do with it. But you mind sharing your screen, maybe walking through something?
Yep. Let me share right now.
Okay. And as you pull up your screen, I think what we just want to do is show the audience what it means to have clusters embedded in the memory of your system, and how it can be accessed quite easily through natural language. And then we can talk about how we've done it and how you make it scale. And there's some really interesting technologies behind the scenes. Go ahead.
Yep. So here we have a test org where we have hypothetical tickets for a B2C payment processor. So we have the tickets be clustered based off of the unstructured conversations and the situations regarding the tickets. So to access this data from a search perspective, you could just simply ask, can you show me the clusters of the recent tickets?
Mm-hmm. And so while you're waiting for those results, I just want to remind people what you're seeing here is computer. And computer is available on a lot of surfaces, mobile, desktop. Here we're checking it out on the web. And of course, if anybody has questions about computer or wants to ask us more about it and how it works, then you can meet us up on the Discord server. So we'll put up the data on how you can connect with us. Our Discord community is always looking for more and more people to talk to. So we welcome you there. And in the meanwhile, Justin, what are we seeing here in terms of thinking and so on? What's happening?
Yeah, so the agent is actually has a goal in mind of trying to find the clusters. In this case, we have a cluster field tied to the ticket. Again, the clusters are generated through a clustering methodology that we'll go over later, but the agent is breaking down the problem into these smaller tasks of trying to run the query to find the data that you ask for. So in this case, it found the most recent cluster. If we ask, can you plot can you show the cluster amounts in a table, you'll be able to get a high-level overview of the recent tickets and what clusters they fall into.
Outstanding. So really what's happening is what you're showing us is that behind the scenes, we have been able to generate clusters. And we'll talk about what clusters can mean semantically and how they can represent all manners of intent, because there's not just one intention when people are looking to cluster based on the type of information it is, maybe your persona, your use case, or maybe the question itself. There could be many different intents. And so you need to have the ability to cluster on many intents and to retain that information so that people can get answers. So what are we seeing here?
Yeah, so here we're seeing in this demo use case for a payment processor, we're seeing what the clustering methodology actually found as emergent themes of friction points with your customers. So in this case, we have a table of all the clusters, the themes essentially around the tickets. And here you'll actually be able to find the pain points within your business and tackle them one by one, and be able to spot emergent themes as you run this clustering methodology over time.
Wow.
In this case, I generated 25 distinct themes, and you could see kind of what your customers are actually talking about.
I love it. And Manan, am I right? We don't actually need to provide these categorical names. This is all generated based on intent and obviously understanding the schematics of the data. Is that correct?
Yeah. So all of this is figured out from the data itself. Like, we're using some complex algorithms which are trying to figure out the intent of your clustering intent per se, and then categorize all of these tickets into them. So nothing of this sort is kind of like predefined. It is all figured out when we do the clustering part and find out themes across your data and then show it to them in this format. And computer comes in with business context and kind of like defines how to show it to you or how to communicate that to you. So it's like both things coming together. There's clustering, and then obviously there's a business context part of computer, which is like powering it.
I love it. Okay, so there's another question here, because you could obviously, it doesn't have to be at the highest levels. You could start to say, show it to me based on just the highest priority tickets, or in this particular case, what's the question you're asking, Justin?
Yeah, so again, this is a conversational interface. So one of the key points is we can actually break down the clusters into different aggregations, so you could see what the specific pain points are for specific customers. So in this case, I'm asking to create essentially a pivot table of which customers are putting in tickets for which clusters. Like, what are the thematic categories that specific customers are facing, and you'll be able to see really go deep dive into what are specific customers' pain points, and you could find these emergent themes based off of the different categories of the customers and whatnot. So in this case, it's just by customer, but we could continue asking these types of questions to really dive deep into certain problems.
Absolutely. And this just shows sort of the value of being able to do this type of natural language insights, analytics, what have you, because you're not sort of limited to by some artificial cardinality to say, you know what, I can't break this down by priority, or I cannot break this down by customer because I don't have that level of information. Here, all the information exists, and you can create whatever table you want. If you wanted to say, I wanted to see it emergent behavior by customer, or by by product category, or by time, or by priority, you can do that, because all of this information exists in your system of record. And all what we're doing is creating sort of a long-term memory model on top of it that's been augmented with clusters to be able to give you even better answers. So what are we seeing from your query here?
Yeah, here we're seeing a pivot table where it takes the top customers in terms of ticket volume and maps their tickets and some of their problems into the clusters that were generated. And here you'll be able to get a breakdown of who's having what problems, and also what problems are showing up most frequently for specific customers. And so in this case, like Susan, again, this is test data, but Susan had a lot of issues with payment method friction. So you could really do kind of this deep analysis on specific customers now that you know these specific problems exist.
That's right. And you could obviously, ask a question and say, just show me those 4 tickets where Susan's having problems with payment method and so on. So, well, actually, you're actually going to do it. I was just saying that theoretically, but yeah, let's do it. What I find really interesting about this is that the same technology that's powering the ability to build this ticket is fully going to give you cited and grounded answers, but you can take it from this conversational scheme. You can take the same SQL effectively and create a dashboard off of it. And you can share that dashboard in a board meeting. You can share it in a team leadership meeting. And so you can, start single player and very quickly get to multiplayer. And Manan, after this, Justin, I know there's probably plenty more you can show here, but after this, what I'd love to do is maybe start to talk to Manan about how we've put this together, what the multi-step process looks like, and how we made it so efficient and so cost effective as well.
Yep. I will stop sharing. We could just I'll pass it to Manan to talk more about this.
Yeah. And Justin, I think like we saw those results. Thank you so much, and we might come back if we have some time later on to see more. But Manan, walk us through, what the experience looks like behind the scenes.
Right. So behind the scenes, we kind of run this whole process of clustering in a serverless environment. So that is very important for this to be highly customizable, easy to build, and kind of have a control over the resources which are being used. Because when we look at these kind of ML native algorithms like clustering, they get very heavy on memory. So that is one thing we had to work around with, that how do we kind of take care of the footprint? How do we kind of take care of all of these other parameters? And how, because it is a serverless environment, we need to conclude and converge the whole algorithm in under a span of 15 minutes. So with all of these constraints, we kind of moved on to develop this algorithm, and it fits in all of these constraints and kind of is a highly customizable piece of software which we have written, which can actually cluster across objects, across themes, across intents, and how we actually made that happen is something we can dive into next.
Absolutely. So let's do that. It starts with, and we're not going to get into all the secret sauce. Obviously, there's some pieces that we're not going to mention, but I think for the benefit of the audience, we do want to talk about the different steps and what are the categories of algorithms that are necessary to do something like this. And also what puts us in a position to uniquely be able to offer this. So we'll talk about all those things in the last 15 minutes here, but walk me through, starting with intent classification. Tell me about that.
Yeah, so when we were thinking of clustering, one of the most common problems which came for enterprise customers is that there were different themes of data which they wanted to find out from clusters. Like, it was never the same thing. So there could be someone like a product manager which would want to see that, okay, what are my customers complaining about? What can I fix in the product so that these tickets do not even come in the first place, right? Or there could be a support leader who thinks that, okay, which are the most frequent bugs which my customers are reporting? So the underlying data is kind of the same. It is the customer conversations which you might have on your tickets, or let's say any other chat interface you might have, but the intent and themes they want to understand from it kind of vary a lot, and you can never classify them into what they could be. So the first step we did is this intent extraction part. Like, first we kind of promptify it via computer that, okay, what do you actually want to cluster on? Like, do you want to cluster on like product gaps per se, or do you want to cluster on engineering bugs? Do you want to cluster on customer sentiment? That is the first part of the step. So we kind of use our workflows in DevRev, like, which are a very powerful feature. We kind of take the ticket context and use intelligence, the business intelligence which computer has, to extract these intents out of that data. So it would actually read through the customer conversation, right, and figure out that, okay, the customers are saying that, okay, this button is not working, or my app performance is too bad, or dashboards are not working. And it will be able to find all of these things and kind of extract them out on a per ticket basis, right? So what we're doing is we're reducing the search space and the noise, all of that, and extracting them into high value signals. And because this part of the data is very, very crisp and very low token, it kind of helps us to bring down the cost and computation of clustering which comes forward. So this first is doing the heavy lifting of reducing all the noise which your data might have and converting them into strong potential signals for you.
Yeah, and Manan, as we understand, like, obviously the concept of vector embeddings, because of the explosion of semantic search, people really understand this concept. And if you're not familiar with vector embeddings or semantic embeddings, obviously you guys can take a look at it or join us on Discord. We can talk about this ad nauseum. But the general idea here is that different embeddings can cost you a different amount of money, because you can have a lot of parameters or you can have fewer parameters. It's how long is your vector, right? So exactly. So the dimensionality matters here, and of course also the precision of the values in your vector. So in this particular case, by leveraging intent classification, you can actually optimize your vectors so that they don't cost you as much, which I think is really fascinating. But once you have intent, what do you do next?
Right. So after intent, we convert them into embeddings, and these embeddings are not just like your normal embedding model. They are actually converted by a fine-tuned model for your business context. So it has that kind of context being encoded in the embeddings itself. So the words and terminologies which might be extracted, they are something which the embedding by itself holds the meaning of. So we convert them into these embeddings, right? And these embeddings are actually lower dimensions than what you would expect for this amount of data, because we have done the heavy lifting of signal extraction. So let's say if you were sending the whole ticket data, you might need, let's say, 1,000 or 2,056 embeddings, right? But once you have good signal extracted from it, you could cover up with a very low dimensionality of vectors, because the noise to signal ratio has been compressed down so highly.
That's right.
So the second part of it is we convert all of these into embeddings, which kind of encode your business context, their attention aware, and so on and so forth. And one important thing we do is, and this is technically this is something maybe we can talk more on the Discord channel, these vector embeddings are L2 normalized, which means the kind of scalar quantity of these vectors will always equal to be 1. And why that helps us is the second part of the algorithm, which is clustering. The clustering algorithm we use is k-means plus. And in that beautiful algorithm, the Euclidean distance computation becomes same as the cosine distance computation when the embeddings are L2 normalized. So we basically are leveraging cosine similarity for figuring out how closely these embeddings are created and how closely they might be corresponding into clusters using cosine similarity. And one step which comes before that is for sampling, right? So this directly going into clustering, we can converge it very easily at around 100K entities. So if you have 100K entities, you do not need sampling. You can just run the system as is. But once we're talking about like 1 million entities, we need some form of sampling coming in the picture. And that is where we have like these complex algorithms, which are, because random sampling does not work. It is highly biased towards the most common data, and then it can lose out on low frequency signal. So we also talk about how we get into, we can also talk about how we kind of create this diversified sampling out of it. But the second step is these highly valuable embeddings, which we create out of it. And the part is that they are L2 normalized.
That's right. And of course, people are probably wondering, well, if you're processing all this information, you're creating all these embeddings, obviously the ability to create these embeddings, we already have all of that within our system. That those are all just features of our platform. But also, more importantly, as you're producing all this information, you need a way to manage this state, and of course you want to be able to do it in an efficient way. So the stateless compute that you talked about, the reason that's so important is because now we can process as much of this as possible. So even if we have 1 million or 10 million customers that want to do clustering at the same time, or there's been an automation that's triggered clustering based on some event or some schedule or whatever it is, you can do that and we can swarm on it. There's no problem because it's stateless compute. We don't need to do any kind of scaling action on our side. That's the first important task. The other thing is the fact that even though it's stateless compute, we have a way, because our system has persistence built in, memory built in, we can leverage our own memory model to actually manage state periodically, and then even at the very end. And ultimately, the state that we produce gets attached back to the entities, whether they're tickets or opportunities or incidents, cases, whatever they are. And so we have a full stateless swarming methodology here that can be triggered in any which way that you want, whether it's on schedule or based on an event or a webhook or some external action. Or if you're worried about just the sheer amount of information that's going to have to be collected and computed, we have state management intermediate and permanent built into our platform. And these are really important steps that you need to be able to carry out. And if you don't have those solutions in your platform, it's going to be very difficult to put together the set of actions that we need to take. So I know you talked about the embedding piece. Walk me through where you go from there, because I know you're looking for how good a clustering we've done by seeing if we've over clustered, under clustered. You're using various hashing techniques. Walk me through that as well.
Right. Yeah. So I think the first part of it is to get a good stratified sample out of it. And this is just like a 1 million kind of a case. Under 100K, we do not need to sample. We are very quick and efficient on that. But let's say you are talking 1 million entities, which actual enterprises have, that's a very real use case, and we have solved for it. What we do is we create a stratified sample out of your embeddings. So there is this algorithm, this very beautiful algorithm called locality sensitive hashing, which kind of is able to figure out how close embeddings are in the vector space, right? Based on certain planar dissections of the vector space. And for every single one of these buckets of data, which this algorithm creates, we kind of use these representative samples to run clustering, right? And these samples are much more diverse as compared to random sampling, because random sampling favors, it's skewed towards real distribution, right? So you will always be on the low frequency valuable data, but LSH kind of takes care of that. So we get this representative sampling, and then we use k-means clustering on top of it. And k-means clustering is the algorithm of least memory footprint, right? And the best part about this algorithm is that it's only dependent on the number of clusters, the number of embeddings and the number of dimensions. So no matter how verbose your signal is, let's say your intents are very verbose, or you might have made a mistake on that part, because they will always be converted to a particular set of dimension of embeddings, the actual clustering is independent of the number of tokens in your signal. So your signal could pretty much be very verbose, but because your embeddings are of a fixed dimensions, you can be sure that clustering will always work predictably. It will
And
not.
Yeah. And predictable and consistent is going to be important here, because remember, we're not trying to provide a clustering solution that works on a particular intent, nor can we actually have any sort of ad hoc understanding of what the distribution of the data is. It's possible that pretty much every ticket you have in your system, because there's an incident going on, is about logging failure, right? So if you're trying to do a clustering on today's tickets, and you have 1 million tickets or 10 million tickets, and they all have to do with logging failures, you do not want the performance of the clustering to be impacted by that. And of course, the fact that we are not impacted by data distribution or intent classification means that the shape of the data is not going to impact the performance of this algorithm, which I think is super important. Go on.
Yeah. So that is like the one thing which we solved for, that your intent should not affect your predictability of clustering. So that is what we take care of here. And after, let's say, the clusters are figured out, a very important steps come into place, that we start using LLMs as they were supposed to be used, right? Like the right brain of the system, like as judges of clustering. So the problem of k-means, which some people assume, is that you have to provide the number of clusters upfront, which most people could not be aware of in the system. So that is where LLMs we leverage LLMs and use their intelligence to kind of help us with. So every single cluster which we create and the stratified sample of embeddings around it are sent to an LLM to kind of inspect if we have over clustered here. So this LLM, based on this huge amount of stratified data, is able to say that, okay, is this cluster actually enclosing multiple themes? And if that is the case, it will actually promote this sub-theme as a cluster by itself. So even if you might have over-clustered, maybe you have a K which is like too small for the true number of clusters, this LLM sits here as a fallback for you and kind of promotes these sub-themes into clusters by themselves, like independent clusters by themselves. And so this LLM is taking care of over-clustering. And then what happens is all the superclusters, supercluster is not the right word, but the top level clusters which we have figured out, which could be, subclusters before, but now they are top level clusters, they kind of go into one long context window LLM to kind of figure out under clustering. So this long context LLM is now looking at all of the clusters possible and understanding if two of them are way too similar. So
That's right.
the first LLM was taking care of over clustering. The second LLM is taking care of under clustering. And the final amount of clusters you see are outputs of these two, kind of like a sieve mechanism, which is much more representative of the real data. So even if you have screwed up your value of K, it just needs to be like a close estimate. These two LLMs kind of make sure that the clusters you get are actually truly representative of your data.
Awesome. Yeah, and I like the way you put it. Like you have sort of the left side of the compute, and then you've got the right side brain, which basically says, does this make sense? And again, we're doing this, to get almost a human level sensitivity, to the overall output. Because at the end of the day, we want to be able to create categories that make sense to humans and humans can take action on. And that's exactly what's happening. What's wonderful about it is that after all of this is done, you're actually going to create this output and you're going to store it. And it's possible that you're doing this daily. It could be that you're doing this every 3 hours, what have you. Eventually what we do is we actually lazily attach the facts back to the entities that we were clustering on top of. Is that correct?
Yeah. So all of this is being backfilled, and that too lazily. So let's say we have figured out all of these cluster dimensions, and then after this has been complete, and we require a human in the loop approval that, okay, I like the clustering results, like this is actually something which is of value to me. You can trigger this part of it, and lazily all of the tickets get assigned to this cluster. So what Justin was beautifully able to demo to us, that is the clusters which were created by this algorithm propagating back to the tickets. And once these cluster names are in the schema itself, you get the superpower of kind of slicing by any other field possible. Like Justin was able to show. He was able to show that, okay, what kind of problems was Susan encountering? Or what kind of problems came in the last 7 days only? Or what kind of problem distribution I want to see per customer. So now you're able to create all these pivot tables because the schema between rest of your customer information and your clusters are now shared. So that kind of unlocks the superpower, and all of this is happening lazily in the system once you kind of approve what the results of clustering are.
Amazing. I love it. Is there any, Justin, anything you want to add to this? I mean, like, obviously we've looked at a few examples from you, but how do you imagine this being used in the future? I mean, we saw some of your test examples, but when you start to think about the art of possible here, what else comes to mind?
Yeah, so this methodology is super powerful, and we've seen this with both internal and with clients, that you could utilize the results of this clustering methodology to achieve real business outcomes. One of the biggest results of this is knowledge gap detection. So you run these clusters and find these emergent problems, and you could compare it against whatever you have in your knowledge base that you send out to customers, like Q&A or some sort of documentation. And if there's a gap there, that's something that could help increase the amount of deflection you have with your support team, which will save a lot of time from your support team dealing with these repeat problems. And secondly is around problem drift, is when there's these emergent problems that come into picture, you're able to spot them way more quickly and solve them a lot more quickly for your customers, which again helps with retaining your customers and making sure that those problems don't propagate for the rest of your customers down the line.
Yeah, and I like the word you're using, emergent, because what's happening is we are establishing proactive insights inside the system of action. And so you can now start to retrieve answers and act on it. And the answers are not just based on information that's come from different SaaS tools that you use that we're sitting next to, but it's also introducing new insights that are emerging as the data is being changing or coming into the system, and periodically you're going to cluster this information based on whatever actions, triggers, schedules that you have in mind. So I find this to be really fascinating from that perspective, and what it really kind of brings to light is the fact that modern search depends on emergent behaviors being accessible. And so modern search is not just based on this transition we've seen from keywords to semantic to RAG. Now we're in sort of this new emergent search world. And what it means is that you have to not only have an index to the information, because the fact is, Manan, am I right? You can't do this if you just have an index to your data. You can't build clusters off of embeddings or indexes. You need full fidelity access to information.
Yeah, you're right. I mean, both for both things, right? First, the important part of it, you need to understand some business context to create good embeddings out of it, right? And for that, you need information across channels. And the second part of it, indexes are very, they do not hold the kind of information which is required for thematic analysis. And they would never be intent specific. Like, you would never be able to figure out what kind of clustering you want based on intents. You need something full fidelity to understand the intent, extract them out of business context, and then kind of move them into clusters. This is a 3-step process, and out of which the first two by itself, a single index will never be able to do.
Absolutely. And secondly, so I mean, if you're trying to federate information, build an index off of it, you're not going to be able to create emergent insights because you won't be able to do clustering. The second big, I think, observation here, which I think puts us in a unique position here at DevRev with computer, is the fact that memory has to be able to contextualize any entity in the context of product, customer, and work. So if you're talking about an incident, or if you're talking about a ticket might be some sort of a work item that a customer success person internal to your business or external to your business has to operate on. But that's in the context of a customer, and that customer has a history with you. And it's also in the context of product, features, services. And that has obviously a history within the company in terms of how it's being invested in, who's working on it, and what kind of work is coming up in the pipeline. And so to be able to have the ontology, to be able to actually relate work, product, and customer together, that's the best way to create what I would call full fidelity information memory, long-lived memory, in order to do proper clustering. Otherwise, what you're going to do is do clustering in a rather sort of sheltered or cohort way. And that's going to give you, it can obviously give you clusters because it will never refuse to cluster. But of course, if you have all the context, you're going to get better clusters, better intent, and a better signal. So I think, and Justin, I mean, have you seen that? Because some of these questions that you're asking, obviously you're taking tickets, but there is information that's backing these tickets in terms of maybe there's work that the product team has to do, or perhaps there's a history for that customer. All of that becomes quite evident here. I mean, in the example that you shared where you're showing these tickets, you can actually click into these tickets and you can see with full fidelity what the history is. And you can even also see if any work has been sort of escalated to a product person, or who's assigned this work, which customer, and so on and so forth, which I think is really important in terms of the actual actions that you might take after your answers are retrieved. Am I right?
Yep. Yeah, and we've seen this with customers who have used this methodology where they basically are able to drive deep insights into the problems and circle the dot with other teams about when these emerging clusters occur. These problems don't occur in a vacuum. They happen, and you need to be responsive about certain themes that could be affecting your customers. So a lot of the times you find the high-level clusters, and then you drill down to the actual problems of what the customers are facing, drive into the tickets, what products or services are tied to those tickets, and you're actually able to get a full picture of what sort of problems you're looking to solve. This is highly valuable insight, and you could catch these problems a lot quicker using this methodology because you, again, have this full fidelity of the whole picture of all the clusters and all the problems that you face within your business.
Yeah, complete picture. I think that's what it is. So I think this is our 30 minutes for today, folks. I appreciate everybody joining, and those who watch this later on YouTube or LinkedIn or wherever you find it. Thanks again for joining us. What you've seen today is how we've effectively made search even more emergent, even more actionable by proactively creating information that sits alongside your system of action to be able to give you better results, better answers, smarter answers. And it's all because we're able to bring long-lived memory across a lot of different products that you might be using, having that information coexist in a way that allows us to draw intent, draw insights, and then put that back into a system that you can retrieve conversationally. I hope you liked what you saw today, and we'll keep doing these every week. See you next time. Take care. Thank you.
Thanks, folks. Thanks.
Yeah. Thank you, guys.